Number 9, we want to find f of g of 16. So f of g and then 16, that means f parentheses g of 16. Okay, so first we're going to start out by plugging 16 into the g equation. So we're going to do g of 16 first, and that's going to give us 4 plus the square root of 16. You plug that in for x. Square root of 16 is 4, so we get 4 plus 4, and then we get that that is equal to 8. All right, so we got 8. So from here, we're going to plug that in, so f of 8 now. So what we're going to be solving for, f of 8, we have big square root, and we have 2 times 8 under the square root divided by 3. And they want us to round our answers to 2 decimal places if necessary. I'm looking up there. So what we're going to do here, this is equal to the square root, big square root of 16 divided by 3. And then we'll just let the calculator compute the square root of 16 divided by 3. Now, there are ways to simplify this by hand a little. When you have a fraction under a square root, you can think about that as written the square root of 16 over the square root of 3. Give both the top and the bottom their own square root. And then you can evaluate the square root of 16 to be 4 over the square root of 3, but you will still need a calculator to simplify that part as well. So it says round to 2 decimal places, so that's indicating to me that they want us to use a calculator. So I'm going to show you both. I'm going to show you, let me see, I'm going to show you the whole square root, 16 divided by 3. So if I do this green alpha button, the y equal button, it gives me the option to make a fraction. And then I want to do second square root. Actually, let me clear this out. Let me do the second square root first, and then the alpha y equal enter. And then the fraction that's under the square root, I can do 16 over 3. Show you what that is. And then I can do alpha y equal enter, make the fraction, and then do 4. And then on the bottom, second square root, and then 3. You should see the exact same decimal answer. So we're going to round it to 2.31. All right, now to number 10. We got the following functions. We're going to find the formula for f of g of x, and then we're going to find the domain. So here are those domains with composition of functions. They're different than the f plus, f minus, f times g, just a little bit. Just a little bit different. So we're going to do f of g of x, which means we want to do f, and we're going to take the g of x and plug it in to f. All right, so I'm going to start with the f equation. When we do composition, you start with the outer function. So the outer function is equal to the square root of x minus 4. So I'm going to leave a blank space for the x, and I'm going to put my minus 4. We're going to be replacing x with the g of x equation. So g of x is equal to x minus 2 divided by 2. So in the place of x, we're going to do x minus 2 divided by 2. So this is how composition of functions work. This is equal to f of g of x with a function. You take the outer function and then you plug in for x the other function. So this is what we get. Now, I don't think there's much that we need to do with simplifying. We can get a common denominator and simplify these two, but I don't know if they want us to. Let's go ahead and do it. If I rewrote 4 as a fraction with the denominator of 2, so think about 4 over 1, I have to multiply by 2 on top and bottom. So that would give me x minus 2 over 2, and then minus 4 times 2 is 8, and then 1 times 2 is 2. So we have the same denominator. I can combine these. So the 2 and the 8 I will combine, and that will give us square root of x, and then negative 2 minus 8 will be minus 10, all divided by 2, and that's the simplified version of that. So x minus 10 over 2. Square root fraction x minus 10 over 2. All right, now the domain. Okay, you start with the overlap of these two with removing this restriction. And I think I can show it 2 ways just to confirm it. We start with domain of f, domain of f. So domain of f, the f function was the square root of x minus 4. So we have an even root. So the restriction is whatever's under the root, which is x minus 4, has to be greater than or equal to 0. You always do greater than or equal to whatever's under the root, because you cannot take the root of a negative. When you solve for x, you add 4 to both sides. And so you get the domain of f is x has to be greater than or equal to 4. That means on a number line, we're looking at, say this is 4, and this is going to infinity, okay? And then we're going to do the domain of g. Domain of g, we had just this. We had x minus 2 over 2. Now, we do have a fraction, but there's no variable on the bottom, okay? So, since there's no variable on the bottom, we don't have any restrictions. So we got a fraction but no variable. We don't have a root. We don't have a logarithm. So domain of g is all real numbers. So if I did a whole number line, it would be the whole thing from negative infinity to positive infinity. All right. So we would start with the overlap. Okay, so where do these two guys overlap? It's going to be from 4 to infinity. And then with our new function right here, f g of x, we also have to consider the domain of this and factor that in as well. So now the d of g, the domain of g, didn't have any restrictions. Okay, so well, it actually did. Domain of g, well, actually it didn't have any restrictions. However, if it did have restrictions, those restrictions would carry over to this one. Okay, so actually, let's just look at the domain of this and compare. I think I may be trying to force or overthink what this is, but normally whatever the domain, the function that you plug in, since you couldn't use x and g, I couldn't use it here, but I can use everything. However, with the f, you couldn't use everything. But this restriction doesn't matter anymore because this is a brand new function. So we're going to carry these restrictions over and then figure out the domain of this. So the domain of this guy, we have domain of f of g. So we have the square root of x minus 10 divided by 2. X minus 10 divided by 2. So remember, under square root, whatever is under the square root has to be greater than or equal to 0. So that's what we're going to solve for. X minus 10 divided by 2 has to be greater than or equal to 0. So we would multiply by 2 on both sides to get rid of the fraction. And that would give us x minus 10 greater than or equal to 0 times 2 is still 0. And then if we add 10 to both sides, x has to be greater than 10. Okay. So this is our domain. X has to be greater than 10. So on the number line, say this is 10. As long as we're greater than or equal to 10, this is our domain. So this one didn't have that step that where we carry restrictions into the next one. Hopefully we will get to see one. But the restrictions of f are no longer valid once I plug in g and I get a whole new equation. I only have to consider the restrictions of the one that you plugged in. So if you couldn't use it here, you can't use it when you plug it in here. Otherwise, you're fine. So you start there. You start with this domain, and then you adjust for any other values that you lose. So with this domain, we could use everything, but once we simplified it, we could only use 10 and above. So we got rid of all the negative side and everything that was less than 10. So our domain is close bracket 10 to infinity. Sorry, some of that's running off. We need the half closed open